So, this session will deal with another topic. So, this is related to the lab experiment, experiment 8. So, this experiment says measure the distance using ultrasonic sensor with Raspberry Pi. So, for this program you are going to learn theoretically as well as program. So, this topic is related to the experiment number 8 in the lab session. So, interfacing ultrasonic sensor with Raspberry Pi. Ultrasonic sensor is an electronic device that measures the distance of target object by emitting ultrasound waves and converts the reflected wave into a electrical signal. So, basically this sensor is used to measure the distance. Next, HCSR04 ultrasonic sensor pin configuration. So, this sensor consists of 4 pins. So, we are going to learn those 4 pins. First one, pin 1 VCC. So, this pin provides plus 5 volts power supply to the sensor. Pin 2 is a triggered pin. It is an input pin used to initialize measurement by transmitting ultrasound waves by keeping this pin high for 10 US. Next, pin 3 echo pin. This pin is called echo pin, which is an output pin which goes high for a specific time period, and it will be equivalent to the duration of the time for the wave to return back to the sensor. And fourth pin is a ground pin. So, this is the pin configuration of ultrasonic sensor. Next, these are some of the features of ultrasonic sensor like dimension and what is the input pulse width of the triggered pin, operating current, measurement angle, distance range, what is the distance range it can calculate, and resolution, effective angle, operating frequency range, and the accuracy. These are some of the features of ultrasonic sensors. So, now in order to write the program, first we will see how we are going to connect the ultrasonic sensor into the Raspberry Pi board. So, the 4 pins which we have seen in previous slide, we are connecting to the Raspberry Pi board, that is GPIO pins, 40 pins of Raspberry Pi board. So, VCC pin, that is pin number 2, we are going to connect to the power supply. In this pin, the power supply you are going to connect. Next, ground we are connecting to pin number 6. Next, trigger pin. Trigger pin we are connecting, 12th pin we are taking, and GPIO 18. So, this 12, 18 as we have said, it differs based on the numbering system what you are choosing, whether you are choosing board or whether you are choosing BCM. Next, connect the 330 ohms resistor to the echo pin. Now, on it send your current to the pin 18. Next, last pin is pin 6, we are connecting to the ground. So, these are the connections of ultrasonic sensor to the Raspberry Pi board. Next, you have a program how to calculate the distance using ultrasonic sensor. So, first statement, import RPI.GPIO as GPIO, and we are also importing the time. Time we are importing for whenever you are using sleep method, and GPIO in order to include the GPIO library to write Python program. Next statement is GPIO.setup mode. So, numbering system we are choosing as BCM. Next, we have 2 pins, trigger pin and echo pin. So, trigger pin we are connecting to the 18th pin of Raspberry Pi. In the same way, echo pin you are connecting to 24th pin. Next, GPIO setup. So, you have to put trigger pin as the output and you have to establish echo pin as an input. So, for that you are writing setup method, GPIO.setup, GPIO trigger, GPIO.out. So, GPIO we are providing the direction, that is in and out. So, next GPIO.setup, GPIO echo, comma GPIO.in. So, echo pin is an input pin. Next, we are defining a method called as distance to calculate the distance. Next, GPIO.output, GPIO underscore trigger comma true. So, whenever you are calculating the distance, we are saying trigger value true, and after some time, that means whatever the distance is been calculated by the sensor, that will be shown onto the output window. So, after some time, take some time, some seconds, and then set GPIO output, GPIO trigger false. So, trigger after 0.01 milliseconds to low. First you are making it as high and after some time you are making it as low. Next, start time and stop time. So, whenever you are calculating the distance, you are going to take start time and stop time. So this we are defining with a method called as time. Start time is equal to time dot time method, and then stop time is time dot time method. So here you are saving the start time, whatever the time it has been calculated, you are saving the start time as well as you are saving the arrival time. That means whenever the sensor is detecting an object, it is traveling to that object, that is the start time. After reflecting back to the sensor again, we call it as arrival time. So that you are going to calculate as start time and stop time. Next, while GPIO dot input echo pin, we are saying it as 0 after some time, while GPIO dot input GPIO echo is equal to 1. So here in order to calculate and start stop times, we are making GPIO echo as low and high. So the transitions of the signals, like when it is low, when it is high, according to these transitions we are going to calculate start time and stop time. Next, we are taking another variable called as time elapsed. Time elapsed is the subtraction of stop time minus start time. Whatever you are collecting start time, stop time, you are separating stop time minus start time. The difference between start and arrival time, we are taking it in time elapsed. Next, you are writing the distance formula, how to calculate. Distance is equal to time elapsed into 34,300 by 2. So this is the formula we are writing. So what is the value of time elapsed? Time elapsed value is stop time minus start time, and then you are multiplying it with 34,300. So this is an default sound. You are calculating, this is the default sound which is calculated in centimeters by second, and then you are dividing it by 2. Why? Because it is traveling twice. Whenever it is seeing the object and it is returning back to the sensor again. That's why in the return trip you are calculating the sound wave, forward and the return trip. That's why in the formula we are dividing it by 2, and then we are multiplying with the default sound value 34,300. You will be getting the distance value. Now what is the value that is been collected? You are returning the distance value onto the monitor. Here you are going to write in a if loop, try, expect, and then final methods. So here these all you are writing the way you want to print it on the output window, how the distance should be printed on the output window. If there is any errors, that means if the sensor is not able to catch the distance, or if there is any error, or as a human we are pressing any of the keys. So if there are any errors, in order to check that, we are using the try catch methods. So if name is equal to main, so this is the main loop, where in the try block you are writing while true dist is equal to distance. So here as it is main method, here it is going to start from here. Distance, when it is seeing the method distance, it will go to the previous lines of the code. There it calculates start and stop time, time elapsed, and the formula which we have written distance, and whatever the value you are getting, it is been stored in dist variable. Whatever it is been stored in dist, we are printing it onto the output window. Print measure distance is equal to in meters, and you are taking some time sleep 1 millisecond. So except keyboard interrupts. So whenever you are pressing any, by chance user is pressing any of the keys, so the calculation of the distance is been stopped by the sensor. In such case, this block will be executed and it will be printing like measurement stopped by the user. That is, it is not measuring any of the distance. Finally, you are using GPIO.cleanup. Cleanup is a method as you are installing the libraries like RPI.GPIO. If there are any libraries, usage of any default methods, anything which is not related is been used, it can be cleaned up by this GPIO.cleanup method. So these are the output screens. This is the connection screen, and then on the output window you will be seeing whatever the distance is been calculated, that will be displayed onto the output window. Thank you.